Assalamu alaikum. Today I am presenting this presentation for the competition application of emerging technologies in maritime transportation and logistic industries. My idea is turning anchorage time into green power, a hybrid renewable energy approach to power idle vessels and reduce port emissions. My name is MD Sahedin Islam Tamim. My program of study is BC Naval Architecture and Offshore Engineering. I am from Bangladesh Maritime University. Now let's go to the details. Introduction. Anchorage time is the period a ship spends waiting at anchor outside the port before it gets permission to enter the berth for loading or unloading cargo. It happens because ports often get busy and ships must wait for a berth to become available, customs or clearance procedures, cargo readiness or scheduling, weather or tide condition. Ships spend up to 9% time at anchorage around the world. Ships keep their auxiliary engines running for power, lighting, and onboard systems. For example, in Chittagong port, one of the busiest port in South Asia, ships often have to wait for several days at the outer anchorage before getting a berth. This long anchorage time increases fuel consumption, operational cost, and carbon emissions. It also delays the unloading of goods, which slows down the supply chain and causes the prices of essential commodities like food, grains, fuel, and industries raw material to rise in local market. It also causes CO2 emissions and port area pollution. Now let's go to the next slide and look at the problem in details. The problem is nowadays, due to the increasing number of ships and growing global trade, anchorage congestion has become a common issue in major ports. During this time, auxiliary engine keeps running for power needs of the ship. This leads to continuous fuel consumption and high emissions, even when vessels are idle. The time of ships are many. Let's see one of those. Significant carbon dioxide, nitrous oxide, and sulfur oxide emissions near port areas. Air quality degradation affecting nearby coastal regions. Extra fuel cost of $500 to $1,500 per day per vessel. No productive output, only waiting and wasting resources. Ports face reduced efficiency and sustainability scores. This is the main problem, and this is huge because there is also fuel cost and also environmental pollution. It's a picture idle ships and active emissions. There I'm seeing a ship which is polluting in air. So anchorage time is unavoidable, but the energy wasted during it remains unutilized. Let's go to the next slide. Here is the details of my idea and technology used in this idea. Turning anchorage time into green power. Floating hybrid platform, solar plus wind plus battery attached to ship. We will use solar, wind, and battery in a single platform together. Ships connect to get green power from these sources, and no engine will be running for power. Supplied to ships via cable or wireless link. Here, wireless link is the new technology by which we can transfer energy without without any wire or any link. Solar panel will be floatable, foldable, and lightweight, which is an emerging technology called FPV. FPV means floating photovoltaics. This type of solar panel are very lightweight, and this is very easy to accumulate in the ship. And so we will use this type of solar panel. I give a picture here. This in this type of solar panel which will float in the water. Some solar panel will also situate directly in the ship free spaces. Ocean wave energy can be harvested using modern wave energy converter WCs around the ship while it's steered. We will also use WCs separately and use the power of the wave, and this will also produce a lot of energy in stormy seas. This WCs is small in size, very importantly, and efficient in power production. Some vertical axis wind turbines boards. This is also an emerging technology, can be used to capture sea wind while anchorage. These are very compact and lightweight. This type of turbines are very lightweight. So this is very necessary to accumulate in the ship, what I'm saying in my idea. So my idea in short is use anchorage waiting period for clean energy generation. Floating hybrid platforms like solar, wind, and battery. What I said that we can store excess energy in the battery for later use. Ships connect to get green power from renewable these three renewable energy sources: solar, wind, and wave. Solar and wind units generate power stored in onboard batteries. We'll use this platform when we are waiting outside the port. Now let's go to the next slide. System components are floating solar panels, generate power in daytime when sunlight is available. Wave energy converters, this generate power 24 hours and 7 days a week. This is very important because it can produce a huge amount of energy. Battery storage, we will store excess amount of power in battery. and we can use it later. Smart controller manage and balance energy. This is the type of a device which efficiently manage these three power sources are wave energy converter, small scale wind turbine, floating solar panel. This smart energy controller efficiently manages these three power sources. It monitors generation and demand in real time and decides how to distribute, store, or combine the power. This ensures a stable supply even when one source like wind or sunlight is not available or is low. We can use this device, which is an emerging technology. We will also use power connection. Now let's go to the next slide. Here is the basic of my ideas working mechanism. Energy capture. Solar panel absorb sunlight, wind turbines harness sea breeze, and wave converters extract motion energy from waves. Energy conversion. Each source converts natural energy into electricity through inverters and converters. 3. Energy storage. Generated power is stored in battery banks positioned on the ship for later use. What I said earlier. Energy management, a smart control unit monitors supply and demand, automatically optimizing which source or battery to use. Energy utilization. Ships at anchorage connect via cables using clean energy for essential operations like lighting, heat and ventilation system, auxiliary machinery. This is the idea. Now let's go to the next slide. Here is the environmental and economic benefit. This is very important slide. Here is saves 515 to $1,500 per day per vessel, which is very useful. It reduces fuel use by 10 to 15%, direct cost saving for ship operators during long waiting times. Zero emissions during anchorage reduces oil pollution risk by minimizing auxiliary engine use during anchorage. Supports IMO 2050 targets as IMO aims for net zero greenhouse gas emissions from international shipping by 2050. We know that IMO is looking for green ship and green ports. My idea is supporting this. In next 10 years, it will be very useful. Improved air quality around port and coastal zones. Support smart port integration, linking renewable generation, vessel monitoring, and AI energy management. There is a picture there that we can save money and we can also save environment by this idea. Idle time no more, clean power, smarter ports, greener seas. Now let's go to the next slide. Here is the emerging technologies that are used in this idea. Hybrid renewable energy integration. Floating platforms equipped with flexible photovoltaic panels and small vertical axis wind turbines. These type of floating platforms are in early use in Norway and Japan. So we can take help from Norway and Japan. This is the picture that this solar panel and turbines are connected and it will float in the water. Infinity WCs, this is also an emerging technology. Ocean harvesting technologies delivers 500 kilowatt continuous, uses a new ball screw power takeoff, good power relative to size. This is the infinite WCs. Its size is small, but it can produce a lot of power. Advantages is continuous power generation even when one source is low. Smart energy management. Sensors collect data on sunlight, wave motion, wind speed, and ship demand. AI algorithms switching sources automatically for best efficiency. Example, WCs are best for energy production in stormy sea anchorage. Smart management is the device what I said earlier that is that smart controller device. This is like almost like it. Now let's go to the next slide. Practical implications of my idea. The practical implications of this system will reduce fuel use and emission at anchorage. What I said earlier, anchorage becomes an opportunity, not a delay. Alignment with IMO 2050 goals supports greenhouse gas reduction target. Scalable for developing ports, even small coastal nations can order adopt ships with this technology because this technology is very easy and available. It can contribute to UN SDGs, especially SDG 7, affordable and clean energy, and SDG 13, climate action. Opens new market for hybrid marine tech and renewable ready vessels. Reduced engine wear and low oil use during a voyage. Here is a picture presenting my idea clearly. Technology, policy, money saver, and also environment saver. Now let's go to the next slide. Here is the decision making value of my idea. Ports can be ports can be measured step toward carbon neutral port certification, which is very important in nowadays. Reduces pollution in surrounding coastal waters and increasing concern for many port authorities like Bangladesh. Shipyard encourages eco-design certification and alignment with green vessel standards. Fuel cost will be saved during anchorage time, which will lead to ship owners flexibility and more profit. Enhances reputation for eco-responsible shipbuilding, attracting clients aligned with IMO 2050 and EU ETS framework. What I said earlier, government also useful for national emission reduction and climate commitment. Green maritime policy development encourage waiting time not will not cost much for government. Attracts foreign investment, green technology partnership, and research collaboration, which can open a new door of opportunities. Now let's go to the next slide. Here is the conclusion. Imagine a vessel at rest, not wasting fuel but quietly harvesting sunlight, wind, and waves. No longer a passive delay, anchorage becomes a moment of transformation. By my idea, by blending hybrid renewables with smart energy systems, we shift from idle emissions to intelligent efficiency in maritime transportation and logistic industry. This vision supports cleaner ports, smarter ships, and a maritime future aligned with global climate goals. It's not just about saving fuel; it's about redefining what downtime can do. Now my idea: idle time no more, clean power, smarter ships, and greener seas. This is my presentation. Thank you everyone. If you want to contact me, my email address is msitamim48 at the rate of gmail.com. Thank you everyone. Assalamu alaikum.